Dear viewers, welcome to the Customer Experience Center at the Panasonic Campus in Munich. My name is Sonja Linder. I'm European Marketing Manager for Industrial Automation Products, and I'm looking forward to today's talk of future mobility concepts. Mobility and its future developments are one of the most important issues of our time because it concerns all of us. Today, we will hear about innovative and sometimes unconventional approaches of our guests. So let yourself be surprised by the concepts of the H2 ThaiGer Racing Team of the University in Stralsund, the Hyperloop team of Ottobahn, and the Ottobahn from Munich. Panasonic Industry has friendly ties to all three institutions, and we are always happy to be able to offer students and innovative companies a platform here in the Customer Experience Center to network and exchange ideas. We are convinced that an open exchange of ideas is necessary to develop future technologies and advance ideas. But that's enough from my side. I would like to hand over to our guests for a short self-introduction, please.
My name is Felix Achenbach. I'm head of safety at TUM Hyperloop, and I'm working there since 2 years now. And my responsibilities are a certification process. Now for our 24-meter demonstrator here in Ottobahn, we already finished it. And then now for the 1 kilometer track. Currently, I'm studying mechanical engineering at the Technical University of Munich, and work now then further for TUM Hyperloop.
Yeah, hi, my name is Sandra Kübacher. I'm a mechanical engineer at Ottobahn, and from the background, I study mechanical engineering, and I'm responsible for the chassis, for the development of the chassis at Ottobahn right now, and happy to be here and talk about futures mobility.
Yes, my name is Ludwig Püschel. I'm from Stralsund, and I'm studying electrical engineering in the University of Applied Sciences in Stralsund. And in my spare time, I'm working in a research project where we build a hydrogen fuel cell electric vehicle. Yeah. And for 2 years, I'm doing this now. Yeah.
Great. Thank you for this introduction round. So our audience may have heard of some concepts you just mentioned. I'm looking at you, Felix, because the Hyperloop was a big thing in the media some time ago related to Elon Musk. So that probably rings a bell at somebody's mind. Hydrogen as a type of propulsion is also nearly an evergreen in the media. And well, Sandra, the Ottobahn is the hidden champion here in our round, so we are all very curious to hear about that later. But so let's start by clearing up our half knowledge. So perhaps Felix, may I ask you to explain what the Hyperloop concept really is, how it really works?
Yeah, so Hyperloop system, in fact, is a high-speed transportation system for passengers and for cargo. And in general, there are several subsystems. So the first and most important subsystem is the tube. The tube connects the cities, for example, Munich and Berlin. And then in these cities, there we have so-called hubs. Hubs are like stations where people can go in and outside in these pods. Pods are our trains. We call them pods because there are only 10 to 15 persons or passengers fit inside. And they all have the same direction. So in Munich, for example, there are 15 persons want to travel to Berlin, and they all will travel to Berlin without any stop in Ingolstadt or Nuremberg, for example. And we can do this because these tubes, we have primary and secondary tubes or lanes. And these tubes are always next to these big cities. They won't go inside the city center. There are these secondary lanes. They switch from the primary lanes in the city centers to these hubs. And from the hubs, you can enter the main lane and the primary tube directly outside of a big city. And this is a real advantage because we don't want to accelerate and deaccelerate all the time. So we can just move through the whole country. And yeah, like I said, we have these pods. We can accelerate till 800 kilometers per hour or also 900 kilometers per hour. This is also research now, what we can do there. And this is our high speed. And how do we do this? So we have two subsystems in our pod. First of all, the levitation system. Levitation means that we levitate without any mechanical connection to the tube. So we don't have any friction, and we can move our pod with a hand. 4 tons with a hand, that's really impressive, I would say. And then we have the propulsion system. These systems are always redundant, so always 2 of them. And the propulsion system is like a big magnet under the pod and coils in the tube. And as higher the voltage is in these coils, as higher accelerations can be reached. So now we have this tube and the pod. And in the tube, we have vacuum conditions. So we only have 10 millibar inside the tube. That's not that much. So we have nearly vacuum. And we don't have any air friction. So we can move through this tube without any resistance. A bit resistance, yes, but not that much like with Intercity Express, for example. And this is a limiting factor. We can't drive faster than 200 or 300 kilometers per hour with a car because the design is on its limit. With our pod, we can drive up to 900 kilometers per hour. This is only because we have this levitation and propulsion system and also this air friction. We don't have the air friction, so we can move much faster. And this is our concept. We want then build a first track, for example, from Munich to Berlin. We can reach then Berlin from Munich in 1 hour. I think this is really impressive if you can compare it to the Intercity Express or to a plane, where you just have to go to the airport and then with security checks and then entering the plane. So it's about 2 to 3 hours, and we are much faster. In general, 2013, Elon Musk developed a first concept paper called Hyperloop Alpha. In this paper, there were different technical details. For example, it was like an air cushion technology instead of levitation. This is different now. But after this paper was released, there were 4 competitions from Elon Musk, and TUM Hyperloop won all of these. So we also have the world record, which is still the world record with 482 kilometers per hour. And there are also a lot of other competitors, like, for example, Hard TT or Hyperloop One, Virgin Hyperloop. These are now also developing Hyperloop systems. But after these competitions, we said, okay, let's build it big, because the pods in the competitions were just small in the diameter. Now we want to build a real-size passenger experience. And this was the reason why we started this TUM Hyperloop project at TUM, funded by the state, by the High-Tech Agenda Bayern. And there we built now this 24-meter demonstrator here in Ottobahn. And our next step is then in the next couple of years, 1 to 2 years, we start with the 1 kilometer track to test high speed. But like I said, there are also other competitors. We are not alone on this market. There are other technical details. For example, some of them hang the pod in the ceiling and lift it up there. We lift off from the ground for levitation, for example. This is, for example, a difference here.
Okay, great. So I did not know that there are multiple Hyperloop teams, so that was new to me. Thank you very much. So Ludwig, let's move to Stralsund and your activities. We always hear about hydrogen as a type of propulsion, but maybe you can explain how it really works with that hydrogen and what you are doing in Stralsund.
Yes, so our research project is called ThaiGer H2 Racing. And this originates from a cooperation between Thailand and Germany, that's why ThaiGer, and the H2 stands for hydrogen. And we are building now since 2007 hydrogen fuel cell electric vehicles. And what that basically means is we have a hydrogen tank in our vehicle. In the hydrogen there is chemical energy stored in there, and we convert it to electrical energy in a fuel cell, and then we feed this electrical energy to a brushless motor, which then converts this into motion. And also we are building not any vehicle, we are actually building an ultra-efficient and ultra-light vehicle. Our car only weighs 22 kilograms. And yes, what's kind of special about our team is that we are trying to do everything ourselves, like from the monocoque or the motor. These are all self-developed parts. Yes.
Yeah, great. So, and that's what I understood from our talks before. You're really focusing on efficiency. Is that right?
We have a competition every year, and this is actually an international competition where teams from all over the world try to build the most efficient vehicle on the planet. Yeah, and we were able to achieve 1,118 kilometers with just 1 cubic meter of hydrogen. Yeah.
Really great, really great. The starting point of our networking here was indeed your ThaiGer Racing Team in Stralsund, because you and your colleagues discovered that one of our sensors here from Panasonic that is used in industrial automation would be well suited for the pressure reducer in your car. So that was the starting point, and in the meantime, this pressure reducer has even won a prize and has even been awarded for its design. So can you tell us something about that?
Yes, to put this in a little bit of context. So in the last years, we only could use parts off the shelf. And if you want to get a pressure regulator, these things are heavy and bulky and inefficient. But in the last year, we were able to build our own pressure regulator. And yes, this is a 2-stage pressure regulator. And as you can see, it's really small. And it's efficient and very light. These are things that are very important to us. Yeah.
Great. So, yeah, very interesting. Thank you. Last but not least, Sandra, can you tell us what the Ottobahn is and what it does?
Yes, of course. So Ottobahn is a new type of transportation system, as Hyperloop is. And I really like to explain it as a combination of a cable car, a train, and a taxi. A cable car because we will move above the ground. So an Autobahn cabin will be above the street and 5 meters high, for example. And a train because we use basic steel wheel rail technology as we know it in every other train. And a taxi because it's on demand. So you can order your Ottobahn with your app on the phone, and it comes to you, picks you up, and takes you wherever you want to go. So you don't have to switch the train, you don't have to stop at traffic lights. No, you go from A to B whenever you want and very fast. We plan on driving about 50 kilometers per hour within cities, and that will be almost the average speed because you don't have to stop for anything. Of course, you could share your cabin if you want to, but if you don't want to, your cabin is like your private car, so you don't have to be with strange people in it. You can use it as your private space. You can maybe watch a film or work while traveling. And when will be Autobahn possible on the streets? So at our current state of developing the system is that we will build a test track in the south of Munich. And we want to test the system there. So from the technical perspective, how does it work? How extensive is the maintenance of the Autobahn? But also we want to show the people that it's possible. We want to show it to the world so that maybe the people in the cities, the people on the street see, okay, this is nice, we want to have this. And hopefully we are able to build it in a commercial application soon, yeah.
Great, great. So we have talked about 3 fundamentally different mobility concepts. That's really, really, really cool. So a provocative question comes to my mind. Which one is the best? Or perhaps let me phrase it in another way. What are the unbeatable advantages of each concept, of the Hyperloop, of Ottobahn, and of hydrogen propulsion? Perhaps Ludwig, let's start with hydrogen cars or hydrogen propulsion. What do you think is the advantage of hydrogen propulsion in comparison to other
for example, first of all, you could say that in comparison to conventional internal combustion engines, you have absolutely no emissions except from steam, water. And in comparison to electric vehicles that also have zero emissions, the charging time is just unbeatably fast. You could just drive up to a hydrogen fuel station and fill up your tank in like 5 minutes. This is not possible with battery electric vehicles, for example. Yes.
Yeah, that's a great point, yeah. Sandra, what about Ottobahn?
So Ottobahn, we are autonomously driven and emission-free. So a big advantage of the concept itself is that we have our own ecosystem. So that's much safer for autonomous driving because we don't, or it's not very easy or almost impossible to access our infrastructure. So it's a big safety issue that you don't hurt other people or the people inside. And another really good advantage is that we don't need a lot of space on the ground. So we use the space up in the air that is still left in the cities. So you can still implement an Autobahn in dense cities very easily. We only need about, I think it's 1.5 parking spaces per kilometer we need on the ground for our to put up our Autobahn, and then we use the space that is left in the air. And to get in or out of the Autobahn, we don't plan on having conventional stations, so there will be some sort of parking lots on the ground, so the cabin can lower down to the ground, and you can get in or out on the without like having stations. Or that's of course a big advantage in the infrastructure costs. Yeah.
Yeah, great. So last but not least, Felix, what about the advantages of the Hyperloop system?
As with Ottobahn, we have a capsule system, but with our tube, we also have, we don't have any problems with, for example, thunderstorms, storms in general, or trees which could crash in our tube. That's not possible to interrupt the traffic in the tube because we have a capsule system. And yeah, we are really independent what outside happens. We just can let our system work. And another feature of our Hyperloop system is if you, for example, want to go to Berlin, like we always have this example because everyone can imagine this length. And imagine at 11 p.m. in Munich main train station, there are only maybe 10, 20 persons or passengers want to leave to Berlin. Now they're always waiting till 12 a.m., 1 hour when they can start their travel. But with our Hyperloop, there's just 1 pod or 2 pods maybe, because we have 10 to 15 persons fit inside, which now travel from Munich to Berlin directly without any stops, like I also said before. And this is a real big point, not just driving a whole intercity express from Munich to Berlin. And it's useless in this case, such a big device. We just need these small pods. And in fact, it's really, with also this high speed, it's really economic than to transport all these passengers. In the night hours, maybe also cargo can be shipped when no one wants to go with Hyperloop. But yeah, in general, it's a really capsule system. And you also can book a pod for yourself if you want a private and not many people in your pod. Then you can book for yourself and just start whenever you want. Our vision is to make the connection between mass mobility and individual mobility. And we think with TUM Hyperloop or in Hyperloop in general, this could be possible to reach this.
Yeah, great. It sounds to me as if we need to move away from the mindset that one type of mobility fits all purposes. But rather think that we need to move towards a flexible mobility in which I choose every day or for every purpose the type of mobility which fits best. Sandra, what do you think? What could the future of mobility look like in an ideal world?
Yeah, in my opinion, the mobility as we know it nowadays is sort of a privilege. So if you want to go wherever you want, whenever you want, you have to have a car and a driver's license. And of course, it's not emission free. So yeah, with electrical vehicles aside, but the fuels in the cars are not emission free. So in my opinion, the future's mobility is flexible. So I can go wherever I want, whenever I want. It's emission free, of course, and everyone, so accessible for everyone, even without a driver's license or small kids, for example. Yep, should be not a privilege, but whenever for everyone and emission free.
Great. Yeah. Something to add from your side, perhaps, Felix?
Yeah, especially this case when you, for example, travel from Munich to Berlin. There are always the thing is, like I said before, the connection between mass mobility and individual mobility. The persons outside, they like their cars actually right now. We need an alternative, and we have to show that there's another possibility to reach Berlin in a really, really fast way, and really not that complicated. Just go in and go outside of the pod, and then you're in the middle of Berlin. And this is together with also Ottobahn and hydrogen cars. You can just maybe travel to Berlin, and from Berlin you take Ottobahn to the next location where you want to go. Or, for example, if you're here in Munich, you can just take a hydrogen car. My parents, for example, live in Bad Aibling. It's really far away from here. There's no that big traffic to this city. There you can take the hydrogen car because it's not possible to have everywhere the same infrastructure. And I think we need the different infrastructures for different situations. And I think also this is the next mobility, just the use case. We need to see what use case we have and which mobility is the best for this. Not the car to drive to Berlin with 8 hours. It's, in my opinion, the train, or then when we have it, the Hyperloop. And for small connections, Ottobahn, and then for longer distances, but not that long, hydrogen cars.
Yeah, I see. So especially the Hyperloop and the Ottobahn in particular are quite visionary mobility approaches that sound good. But I and probably many of our visitors or viewers here wonder how exactly that can be implemented in the future. So what specific requirements are needed so that we can use the Hyperloop, the Ottobahn or the hydrogen car as a matter of transport in our everyday life? So perhaps Sandra again, what obstacles do you see in the realization of the Ottobahn?
So you're right. We need our own infrastructure, but as I said earlier, we don't need a lot of space to build it, and also it's very cheap. So one might think it is not, but so our current situation is that we are like much less expensive as, for example, a S-Bahn or train line, and we don't need a lot of space, so I think space won't be the problem. But of course, you have to convince the people in the city that Ottobahn is a nice concept, and they have to accept it. And that's what we try to do with our test track. So we want to show the people in the world that it's a nice concept, and hopefully everyone wants it in the future.
Yeah, right. Felix, regarding the Hyperloop, we already heard you need tubes, which need to be built, I think.
The infrastructure for Hyperloop is a complete new one. So we need these tubes, like you said, they connect the cities. But next to the tubes, we also need hubs, like stations with trains. We need these hubs. We can connect them, of course, to a central station, Munich, Berlin, or somewhere else. But first of all, we need to drill holes in the cities that we can also enter the pods in the cities in the underground. So in the cities, it's planned to build everything underground, the Hyperloop technology. No one will notice it. And outside of the cities, of course, we have then the tubes and the landscape, but we can also do it underground. It costs much more. In the end, we want to make a system or build a system, construct a system which is not that more expensive like intercity express lanes. So if we can reach this, we are a research project and we want to make research how we can do this in a fast building time and with low costs. Also, of course, to have this high quality. And this is why we research now and doing the 1 kilometer track to see how we can improve our system, make it a bit smaller, a bit wider. We will see this. But in fact, we need the tubes and also the hubs. This is the main infrastructure for Hyperloop.
Okay, great. So Ludwig, I think also the hydrogen cars need some infrastructure.
Same problem. When there are almost no hydrogen fuel stations available. Only in the big cities. If you're living in the countryside, you would have a big problem driving around with your hydrogen fuel cell car. And yes, there's a lot to do in this field. Yeah.
Okay, great. So this means that perhaps not all types of mobility we have heard about today are perhaps not suitable for all areas. I can use my family as an example. We live on the countryside next to Munich here. And I remember when I was young that there was only a bus every 4 hours, something like that. And things are looking better today, yes. But I'm already really a bit sorrowed because our son, who is 3 years old now, will go to some parties when he's older. And I'm really not looking forward to pick him up at 3 a.m. in the morning from this party. And an Ottobahn pod would be really useful for that thing, because, let's be honest, it's quite embarrassing for a young teenager to be picked up by his mom from a party. So, Sandra, is the Ottobahn also intended for rural areas?
Yeah, of course. It's actually my preferred use case too, because I also come from the countryside and the bus is coming 3 times a day. So I think the Autobahn, of course, for now we focus on like suburban areas where there is the need of like connecting sort of the last mile, but also for example, you can use the Autobahn to build one track along the country road, for example. So you only need one track, and it like goes as the Hyperloop goes into the cities. Maybe there is a small part of the track going into the small villages and picking like every village along the way. Yeah.
Sounds great. Yeah.
Yes.
Felix, the Hyperloop, is it also for rural areas or just for big cities?
So I would say it's more for long distances. And for example, if we want to go to Nuremberg or Dresden, for example, in this direction to the north, and we want to make a connection with all these mobility hubs in Europe or in Germany, where we then have at these hubs the connections to Ottobahn or to other like hydrogen cars, parking lots, for example. And we need these connections. In general, it's not suitable for travel to, I don't know, Bad Aibling, for example, in the south of Munich. There we have other options. So I would say it's an option to a plane or also to high-speed trains. So it's in the middle between these two systems.
Yeah, great. So since we have already brought my son into play, of course, it's really important to me that he travels safe. And when I think about the Hyperloop, he sits there in a tube, in a cab, and there is no air around it, and then whoomp, it's catapulted somewhere. Felix, can you reassure me as a mother that it's really safe for everybody to travel with the Hyperloop?
Yes, I can do. So first of all, what are the construction steps if we plan this Hyperloop system? We have inherently safe constructions. For example, the pod. It's the most important thing for the passengers because they're sitting inside and around them is vacuum conditions. It's designed with a higher safety factor than needed. That's the first thing. And it's also, if there's, for example, a leakage, not the whole pod will implode or explode or something like in this direction. It's if this happens, that a small leakage is detected, there are sensors, safe sensors, also redundant sensors, so a really high safety standard, then the pod will, within 5 to 10 minutes, at the next lane switch to the error or maintenance platform, where emergency platforms also are. And there, if it comes to this emergency platform, all the gates can be closed, and there's a section of 24 meters around them, and then air will be repressurized in the tube section, and then the passengers can go out. So this is a first example. And in general, also the Hyperloop will be tested many, many times. And the safety standard, if you compare it, for example, to a plane, it's 100 meters in the air. There is no option to reach the ground within 5 to 10 minutes. You need an airport or some free fields, but in general, it doesn't work to be safe there in really a couple of seconds or minutes. But the airplanes are the safest way of traveling. So our vision is, with TUM Hyperloop, in Hyperloop in general, to make the safest system ever for high-speed traveling. And we don't have any interruptions. No one can go in the tube, and there won't be any damage with pods crashing into something laying around there. It won't happen. Also, we have, when we see this lane to Berlin, we have one direction in Berlin and one from Berlin to Munich. And the pods can't crash into each other because one goes in the one direction, the other in the other. This won't happen. It's technically impossible. And I can really say that's a really safe standard. And with our 24-meter demonstrator, we already have a certification for passengers and from TÜV Süd. And they say it's really safe to go there. We have a CE confirmation there. And also 2 passengers from our team already drove back and forth in vacuum conditions. And was a really successful test 2 months ago.
And I think we have, from this test, we have a video ready we can watch right now.
Ready for pump down. Ready to go. Tube target pressure reached. Okay, we're at 10 millibar and entering the next checkpoint.
Starting levitation. Reach nominal ergo.
Starting propulsion in 3, 2, 1. Congrats everyone involved, we made it!
So we have seen the Hyperloop is very safe to use. Perhaps, Ludwig, what about hydrogen? Because hydrogen is a gas. What about that? Is it safe to use?
So in general, I would say hydrogen cars are safer than it seems at first glance. Of course, there's always a slight danger if you step into any kind of vehicle, regardless of a train or a car. But from my point of view, we're working on this research project for years now, and nothing went really wrong in the last years. And yeah, we have to meet some safety standards. We have pressure release valves and hydrogen sensors that send off an alarm when there's a small leakage or something. But yeah, in general, you could also argue that in comparison to a conventional vehicle which uses gasoline or diesel, hydrogen is lighter than the air and always tries to escape away from the car, where if your tank ruptures in an accident, for example, in a conventional car, the fuel would spill on the floor and maybe catch fire, and then you're trapped in this fire. This would never happen in a hydrogen fuel cell car. So that's maybe a good point on this side.
Good to hear that. Sandra, what about the Ottobahn? Are there any safety topics, issues one should know before using it?
Not that I know of. First of all, it's a private, as a car or a Hyperloop. It's a private space, so you're safe there. And also because we are our own ecosystem, there cannot be any unexpected things on the road, or we would detect it if there is. So if there's a foreign object on the street, on the rail that we don't know, we stop. That's it. So we don't have to decide if it's a car that is moving, because we only have our own cabins in the system. So that's pretty safe, yeah. And of course, we have to consider a lot of certification. We have to use a lot of norms to even be able to be a public transportation system. So yes, I can assure you, it's safe to take an Ottobahn.
Great, good to hear. So perhaps I'm going too much into detail with my last question here now, but can you say something about how expensive will it be to travel with your mobility concepts? So can my son afford, for example, a trip with the Ottobahn, Sandra?
Yeah, so as we plan it, Ottobahn is a normal public transportation system. So it's not like a taxi that you have to pay extra for it. If you own a ticket to take the public transportation in the city you live, you also are allowed or able to take the Ottobahn. So it's not much more expensive than it is to take the normal tram or S-Bahn to get from A to B. So that's our plan. Hopefully it works out. And as I already mentioned, the infrastructure is really cheap to build it up. Of course, you have to build it up, but the maintenance cost, because of the autonomous concept, it's very easy to keep it driving, or very cheap to keep it driving. So hopefully, yeah, it will be a cheap method to get from A to B.
With pocket money of a child.
Yes.
Felix, what about the Hyperloop?
Yeah, so I said before, we are in the middle between planes and high-speed trains. So also the ticket price will be in this middle. So we want to be, of course, cheaper than a plane, because we want to make it possible for everyone to go with a Hyperloop. And we see that it's mobility costs sometimes its price, especially when you travel long distances, for example, to Berlin. The plan is to be around train prices. And I think this is also a good alternative then for persons to take the Hyperloop instead of the train or instead of the plane. But there are also options that you can book a whole pod for yourself, for example. If you want that, then you pay, of course, much more. When you go with 15 persons or passengers in a pod, then it's cheaper, of course. So this is the plan, but we have to do researches here.
Okay, great. So Ludwig, about the hydrogen, so you're focused on the concept car, the racing car, but can you say something about the price of hydrogen in general, for example?
Yeah, that's a really difficult question. I think if I know the answer to this question, I would be a rich man. But it's a personal opinion of my side. I think if the fuel stations are coming in a large scale, then it could be possible that hydrogen fuel cell or hydrogen internal combustion engine cars are able to be as expensive, even in the running costs, than conventional vehicles. Yeah.
Yeah, great. Yeah, thank you so much for all these facts and concrete insights. The time has passed far too quickly, and I think we just have warmed up. But that's what happens when you talk about really exciting topics. I would like to thank our panelists here for taking the time, coming here, talking about their topics. And I think we can all very be excited about what comes next from these three institutions. As a final tip to our viewers here, all three institutions, Ottobahn, Hyperloop, and the ThaiGer Racing Team, has channels on LinkedIn you can follow to be up to date what happens there and don't miss any news. So thank you so much for watching. It was a great pleasure to have you here and to have you virtually here. I hope you gained some great insights. See you next time, and goodbye from the Panasonic Experience Center in the Panasonic Campus Munich.
Panasonic Industry.